regarding the context of our webinar series, if you are new to this working group, I welcome you. The Renewable Buyers Working Group was launched in 2017 by CEIA in partnership with the VLIP team then and now the VLIP 2 team. Our focus is on improving the understanding of Vietnam clean energy procurement among corporate energy users, brands, and companies together with their supply chain partners. We also engage developers, investors, NGO to improve their understanding of the market activities and the challenges as well. Next slide, please. So the Renewable Energy Working Group is co-hosted by the CEIA and the VLIP 2 team. Only pertaining to this event, VLIP 2 is not seen here as CEIA is the main host. The CEIA itself is co-led by 3 organizations, the World Resources Institute, the National Renewable Energy Laboratory, and REL, and other true partners. In terms of funding, we are supported by a variety of partners, including the US government, specifically the Department of State, and also the German government, P4G, and in cases, corporate partners. Next slide, please. So in terms of the activities, perhaps some of you have engaged with us before. For those who have not, CEIA works on a variety of market engagement exercise using platforms such as this webinar series on clean energy topics. We also provide support in terms of policy designs and with a specific focus on clean energy procurement options, notably with topics such as the DPPA pilot and also rooftop solar in the past that some of you might have attended the webinar in June. So we also have a focus on the provision of technical assistance and transaction support with using feasibility studies and case study sharing, which we will have plenty of today on the topic of clean heat and also industrial heat decarbonization. Next slide, please. So going to our topic of the day on industrial heat decarbonization, I would like to bring up that certainly industrial heat refers to the energy input as part of thermal manufacturing processes, while in many industries, industrial heat itself represents quite a large portion of the demand for energy, and in many cases, even a larger portion compared to power or electricity itself. We do find that the attention being given to this issue is nowhere near the same level being given to renewable energy in terms of power and electricity. This is why we took the liberty to include this chart from a recent studies conducted by IRENA and IEA to show how much significance fossil fuels still have as an energy source for industrial heat. And I believe our colleague from IRENA, Mr. Jin Lei, later on would elaborate this topic so much better than I have in this slide. So going back to our local context in Vietnam, from our conversation with major energy buyers, CEIA noticed a rising demand and interest in industrial heat decarbonization. And this is why we are holding this webinar with its agenda as follows. Next slide, please. And today, we hope that we have packed for you a great agenda with an assortment of fantastic speakers from major energy buyers in Vietnam and also international organizations. Many of our speakers are representative of companies that have deployed decarbonization solutions, and they are eager to share their journey with us today. And we also, through this webinar, hope to kickstart the interest in this topic and hopefully answer many of the questions that you may have. Next slide, please. Yes, thank you. So together with our agenda and invitation, we have shared with you a survey that was jointly developed by the CEIA and GIZ, Sustainable Bioenergy Market Team. If there are any GIZ team members in the audience, I'd like to thank you once again for this wonderful collaborative effort. For the audience, I'm glad to share that the survey is still open for input during and after the event. as my colleague is sharing the link in the chat right now. As you can see on the pie chart that's being shown, we have received quite a balanced response from energy buyers, clean heat solution provider, and international brands present in Vietnam. And it was also overwhelmingly positive that we found 17 companies among the survey participants have already deployed decarbonizing solution for their thermal processes, and another 20 companies that have shown interest in future deployment of such solutions. Next slide, please. And with this, with this positive context in mind, I'm not going to hold off from the main event any longer. I would like to introduce Mr. Jinlei Feng from the International Renewable Energy Agency, or IRENA in short. Mr. Jinlei is the program officer from IRENA, an organization perhaps widely known globally for its work on multiple aspects of renewable energy, and he will be presenting to you the wider perspective on decarbonization of thermal processes and to give a broader context for the webinar today. So without further ado, Mr. Jinlei, the floor is yours.
Thank you very much, Tongho. Thanks to the Clean Energy Investment Accelerator for this invitation, which gives me a big opportunity to discuss this very much important topic with all of you. So my name is Jinlei Feng. I'm working at the Knowledge, Policy and Finance Center of the International Renewable Energy Agency, which is based in Abu Dhabi. So today, my presentation is about renewable heating and cooling for the decarbonization of industry. So I see that I'm still waiting for the slides.
Yes, I can't see the slide opening up yet. So let's give you a few more seconds, and we always have the option of our colleagues sharing this for us.
Can you see the slides?
Yeah.
Can you see?
Would you like?
Can you see the slide now? I'm showing. I just want to make sure that you are seeing the slide. No.
Not yet.
Yet. Let me try again. Sorry for the. How about now? How about now?
Yes.
It's perfect, but perhaps it's not the start of the presentation.
Right. Sorry about.
Perfect. Great. Thank you, everyone, and sorry for
the
hiccup.
Thank you. Okay, we can go to next slide, please. So the first question is why decarbonization of heating and cooling are important? Because we all know that they account for more than half of the global energy demand. And fossil fuels, as the moderator mentioned, such as coal, natural gas, oil, accounted for more than 3/4 of all the heating fuels. So fossil fuels burning is one of the major reasons for climate change and local air pollution. So climate change will bring many negative impacts, such as raised sea levels and more frequent extreme weathers. So according to the International Panel on Climate Change, an agency under the United Nations, Vietnam is among the most vulnerable countries. If the world continues to burn fossil fuels like now, in the following decades, at least 50 million people in Vietnam will be exposed to the impacts, the risks of rising sea level and more powerful storms just resulted from the climate change. Next slide, please. The world must work together to prevent and minimize the negative impacts. So the largest emission reduction is needed for industry. From the slides right, you can see global perspective generally decarbonize the global industry sector would need improvement of the energy efficiency, the electrification of appliance, and the direct use of renewable heat, such as biomass, geothermal, and solar heat, and the hydrogen for the very high temperature industries, and also other measures for the hard to abate heavy industry. Next slide, please. At the global level, the industry sector accounted for 40% of total final energy consumption. This share can be different depending on the country context. For example, industrial energy consumption can be very low in European countries, but remains very high in countries with a very rapid industrialization. And like in Vietnam, more than 53% of the energy was consumed by the industry sector in 2019 before the pandemic, and the share will keep increasing in the following decade. So with the global level 40% of energy consumed by industry, the heat consumption contribute for around 3/4. The rest 1/4 is electricity. So again, as you can see, the fossil fuels provide more than 87% of the total industry heat. So next slide, please. So more than half of the industry heat is actually low and medium temperature heat needs. Here we define all the heat demand below 150 degrees as a low temperature heat. This could include boiling, sterilizing, cleaning, drying, washing, bleaching, and steaming, and others. And the heat needs, industrial heat needs between 150 to 400 degrees. We call it medium temperature heat demand. This could increase distilling and dyeing and compression. So all the heat needs more than 400 degrees, we categorize as high temperature heat needs. But this part very much focus on some transformation processes such as steel and cement industries. Next slide, please. So various renewable energy technology can be used to replace fossil fuels for the low and the medium temperature heat. So IRENA actually last year identified 5 key pathways from global level to decarbonize the heating and cooling energy use for both industry and residential. Those 5 include the renewable energy-based electrification, renewable gases, and sustainable biomass, which is very important for here, solar thermal heat and geothermal heat. And also district heating and cooling are key infrastructures. Next slide, please. I would like to very briefly introduce 3 key technologies, but will not go very detailed. The first is heat pumps. Heat pumps are very energy efficient technology. For example, a heat pump with a coefficient of performance, we usually use a COP of 4, usually can consume only 1 kWh of electricity, but generate 4 kWh of heat. So it absorbs 3 kilowatt-hours of energy comes from the ambient heat, which could be from air, from the ground, or even from the water. So in some cases, the heat pump can utilize the industrial waste heat or industrial wastewater, and in this way can save cost and also improve the efficiency. But however, the operation cost of heat pumps very much depends on the electricity tariff and requires necessary policy support, which I will mention later. Next slide, please. A very important option is sustainable bioenergy. For example, especially for countries and cities where have available sustainable biomass feedstock. Some widely used technology include biomass plants combine the heat and power, biomass boiler. In some cases for the industrial park and the area level, biomass-based cogeneration, providing power and heat, or tree generation provides power, heat, and chilled water, can be a good option to decarbonize the whole area with the lower operation cost compared to other renewables. But however, all the biomass use should be based on the sustainable feedstock. For example, we recommend the utilizing of agriculture residue, the forest residue, or organic waste. The biomass use, always keep in mind, we should minimize the negative impacts such as air pollution from the burning, and also biodiversity loss or deforestation or pollutions on the soil and water. Next slide, please. Solar heat is another option where there is a large potential of the solar radiation. So the large-scale solar water heating system can be combined with other solutions to achieve a better efficiency and performance. For example, the solar water heater system can be used for preheating and combined with the heat pump to maintain the heat needs for industrial plants. And based on some analysis by the Asia Development Banks on the existing solar heat for industrial process projects, like in China, the analysis found that investment of solar heat projects is less than the biomass plants. And the heat production cost lower than natural gas. And operation cost of the solar heat plants are much lower than other renewable options. Especially if you look at the right side, in Asia region, the heating cost of existing solar heat for industrial processes projects is much lower than other regions, and it's keeping down. So, but always keep in mind, all the commercial level solar heat for industrial projects, usually they need a combination with other technologies to keep steady heat providing, such as electric boiler or heat pumps. Next slide, please. Companies always need to consider the infrastructure before investing in the specific renewable technology, because long-term planning and also always consider the infrastructure will be necessary to avoid stranded assets. If, for example, there are already natural gas networks and sustainable biomass feedstock are very available here. So replacing the natural gas with biogas with biomethane and utilizing existing gas pipeline may be a better option than building a whole new system. Next slide, please. There are 3 models to procure renewable heating and cooling, but I would say in Vietnam and also most of the developing countries, the most common way may be self-generation. That's the only way we can have. So in this model, companies need to build their own biomass boiler or heat pumps or solar water heating system, and usually combine with the storage system to provide for self-consumption. In this way, you always need to consider all the front cost of the system. But when the market is growing at some stage, companies may also possible to purchase renewable heat or chilled water from utilities, or even renewable certificate like what we do for the renewable electricity. Next slide, please. Even all these technologies are available, renewable heating and cooling remain very low because of existing barriers. The barriers companies usually face include, the first is being locked in the fossil fuels. For example, a company just invested a very efficient new natural gas heating system, which can last for around, let's say, 25 years, even longer. So in the next 25 years, this company are locked in the fossil fuels, the natural gas. Other barriers also include high upfront cost, the lack of access to finance, few reliable and available technologies on the market, or long and complex government approval process. The government policy are necessary to enable and accelerate the deployment. Just to give one example, like I mentioned, heat pumps will be very important to global level for the future decarbonization industry heat. But heat pumps using renewable electricity, very efficient and low carbon. But the government need to provide enabling policies, such as time of use electricity tariff and proper mechanism to enable the companies, they can purchase renewable electricity. If policies are in position, usually the companies or factories can use the electricity in the valley time, let's say midnight, at very low price, and store the heat for the all-day operation. It can also buy the renewable certificates or directed by low-cost solar power from the nearby solar plants. But if these policies are not available, the renewable options can be very expensive and inaccessible for companies. Next slide, please. Actually, companies can also take action to decarbonize their energy consumption. The first is setting direct and indirect targets. That's a priority I would recommend to all the companies, because a tailored, clear, long-term and ambitious renewable heating and cooling target based on your own resources would be the first step to guide your company's decarbonization strategy. Among all these suggestions, I would like to highlight that companies should always improve your data collection and monitoring on your energy consumption, because based on knowing all the numbers, you can find the best technology, the best strategy to support the sustainable transition of yourself. In that case, you can achieve more economic benefits and contribute for the global low carbon development. So that's all I would like to share today. Thank you very much.
Thank you so much for the insightful presentation and on information on the broader context, also the number of solutions that there are in the market right now, Jin-Lei. I think immediately I have seen a lot of questions from the audience, and certainly if you could, there is a common questions on the definition of sustainable biomass in the market right now, because I think Matthew, one of the participants, brought up that there is like a lacking in terms of a common and very standardized definition for this. I hope you can kind of provide further insights on this topic.
Yeah, I would like to maybe 1 minute first. Sustainability of biomass, a very, very complex topic. I would say it's very difficult. I give a standard definition here because there are already a lot. I can see dozens of definition on this, and most of the organization they cannot have a grade on this. So it's very complex. But second, I would say 2 things. The first, there are already on the market a lot of certificates to help the companies to ensure You get
để đảm
understand.
bảo mình hiểu rõ và có cái hành động thực tế để mà phù hợp với bối cảnh tự nhiên, điều kiện tự nhiên, điều kiện trong nước.
There's no global definition. In Vietnam, the definition of sustainability is very different from the UAE. So I don't have standard answer. But secondly, IRENA, for example, I'm now working on the report on sustainability of bioenergy, which is very complex, but I would like to share with you when it's published. And there's a lot of policy recommendation and the best practice on this topic. But I still say the best is fitting the context of Vietnam. Second, there are already a lot of best practice on the market. Just you need to find out which is more useful for you. Thank you.
Perfect. Thank you so much for the insights and bringing up the importance of the local context. And certainly in our webinar today, we will go into the context of Vietnam for this topic. So thank you so much, Jin-Lei, for that. And I would also like to remind the participant that please rest assured that your questions will be answered in the Q&A box, and also many of those will be saved for our panel discussion later on in the webinar. And we also have a Q&A session. So please don't worry if I don't bring up your question now in the interest of time. So I would thank you, Jin-Lei, once again for the wonderful presentation and your insights. With that, I would hope to bring us to the next presentation. I believe our next speaker is Ms. Order. So a very brief introduction from Ms. Order. She is the team leader and the sustainable energy expert from Geres, the Group for Environment, Sustainable Renewable Energy and Solidarity. Please pardon me if I mispronounce the French name, but Geres is a leading French nonprofit NGO working on sustainable development projects across multiple continents. And before leaving the mic to Order, this perhaps is the right time to mention that for the next hour, just like Jin-Lei has mentioned, we will be hearing the local situation in Vietnam with regards to industrial heat, and through a series of sharing from Order and other major brands on practical solutions. So without further ado, Ms. Order, the floor is yours.
Good morning. Hello, and thank you for giving us the opportunity to join this presentation. So Geres is working in several countries, and especially in Southeast Asia. We are working in the garment sector in different countries. So in Cambodia, we support the sector towards the transition to more sustainability together with other partners, including and in Vietnam, our study was much more limited. It was focused on 10 factories that are supplied the H&M group. So we are happy to share more on Cambodia later if you're interested, but today we're going to present our findings from a, let's say, limited study that investigated the heating practices in 10 factories in 6 regions in Vietnam. And it is like almost the examples that are corresponding to the general picture that was given by Mr. Jin-Lei. So it is really a pleasure and a wonderful opportunity to just do our presentation just after his presentation from IRENA. Thank you.
Thanks,
so,
Order.
yeah.
Just briefly, thank you, everyone. This is Peter Ford from H&M Group. I oversee the environment work in Vietnam. We have very strong climate commitments as a brand, mostly focusing around our need to cut carbon emissions by 50% by 2030 and to source 100% renewable electricity. And therefore, we were seeking ways in Vietnam to help us and our supplying factories transition towards this. under the UNFCCC Fashion Charter, we've committed to not onboarding any new units using on-site coal power after 2025. And with the help of Geres, we were looking into what else can be done in Vietnam to help. So this is why this study was so important to us, and very interested to hear the comments from others here, and possible industry collaboration as well, so we can all work forward on this. So thank you very much, Aude, and I look forward to hearing your explanation. Thank you.
Next slide, please. Okay, so this is the big picture that you all know, so let's not spend too much time. But you see that exactly the consumption of coal from the industry has been rising quite fast in the last decades, and the electricity sector is taking strong commitments to decarbonize, but it's not going to be tomorrow, and it's not going to be total. So electricity is a good option, but we have to remember that it is not going to be fully clean tomorrow. Next slide, please. Yeah, and so we know that, so we know more in detail that most of the, a large part, like 3/4 of the energy consumed by the industry in Vietnam is also for heat. So what we saw in the reviewing the boiler library in Vietnam is that in the garment sector, we mostly have coal, biomass, and also oil and fabric waste boilers. Electricity is a little bit more marginal, so it's, yeah, coal and biomass are much present. And Vietnam has high resources of coal, especially anthracite, I don't know how you pronounce, which is mined in the north, but they also import a lot of coal from Indonesia and Australia. And in our research sample, we had 80% of factories that produce steam from coal. So all the factories we have seen produce only steam, and even though they need hot water, they produce steam and they would inject steam to produce hot water. So we had only steam production from either coal or from fabric waste. That was in our that was our sample. Next slide, please. Yeah, so maybe let's not spend too much time on the process, but I just want to highlight that we conducted this study during the lockdown, so we could not visit all the factories, and there was a lot of phone calls, and so there were a few interviews that were done in person, but most of the job was done through phone calls, either from Cambodia or from Vietnam or from Taiwan. So that is a strong limit, and we are very open to all comments and suggestions, because we know that is a very strong limit. Next slide, please. So regarding the biomass resources in Vietnam, we were lucky to have access to the results of a large survey study that was conducted for the World Bank. And so that helps, so the map on the left, it helps seeing where are the hotspots for local biomass. So where you can, where are the best locations actually if you want to use biomass in Vietnam that can be considered as residues or sustainable. Then if we have a closer look at the different locations where we were studying factories, so we see for rice husk, for instance, it's much more limited in the north, but we have much more wood and sawdust from residues from the industry. So when we talk about biomass, we have a wide range of options, And given the discussions we had, especially with experts, we strongly recommend that the buyers would not recommend one specific source of biomass, but to keep the prices affordable, good to look at the best option in one location and for the specific use also that the factory will have. Next slide, please. Okay, so if we go directly to the different alternatives that we have been studying, so we have tried to gather some prices, and we could not really provide only one single picture for the north and the south because the prices were not the same. Even the origin and the nature of the coal used was not the same. So in red you see the figures for the south, and in blue the figures for the north. So our reference in both cases is coal. So we did not try to take any reference from fabric waste because fabric waste has a negative cost, because when you burn it, you don't have to dispose it properly. So we did not take that into as a reference, of course. And you see that there are not so many currently, not so many alternative sources like biomass sources that can compete with coal. So this is of course, we have made assumptions regarding the efficiency of the boiler, and so of course this can vary a little bit, but yeah, in general, it's difficult to find biomass that can compete with coal. So it means when you want to switch to biomass instead of coal, first you need to invest, and as Jinli highlighted, when you already invested in new boilers, maybe 3 or 5 years ago, or last year, as we saw in some factories. So of course, it's not easy. And then your operation costs might be higher if you don't change anything else. I mean, so if you just change your boilers to a biomass boiler, and then you want to change fuel, your operation costs will be higher. So next slide, please. Yeah, so it is again about the sample. So in our sample, we had factories that had very high needs of steam and others that had low needs. We had 3-4 factories that had a large use of hot water for washing and dyeing at different temperatures. And most factories had relatively new boilers. So we're facing the challenge of making the decision of investing in new boilers. And we had only one factory that has very, very large boilers, that has already amortized boilers. So really, we really hope it is an opportunity for them to move forward and to investigate what they can do, investing with in new boilers. And what was also surprising for me is that we did not observe any co-firing process in any of the factories. So because the first step, the easiest step, is to mix biomass with coal, and that would reduce your emissions already. And that's also a good way to get familiar with your biomass supplier, to see what has the appropriate quality, what is the reliability, how the prices are going to vary along the year. So we were surprised that there was no initiative just to try it, just to start reducing the greenhouse gas emissions and to start understanding how the biomass supply can work. Next slide, please. So I said the challenges are on investment, because if you want to mix biomass and coal, you can usually do it in your coal boiler. So if you want to switch to 100% sustainable biomass, it may require investing in expensive boilers. So I just want to say very briefly that, generally speaking, a good biomass boiler is not necessarily more expensive than a good coal boiler. You have different technologies, but you also have different technologies for coal. And the most expensive are usually also, or the most efficient are generally also the most expensive, but it is the same challenge as for coal. So our recommendation would be not only to try to reach the highest efficiency with the boilers themselves, but also have a look at the use of the heat, because in some cases, doing everything through producing steam and using the steam to either ironing for ironing, so as steam, or to produce hot water might not always be the most efficient option. It depends, sometimes it is. But mostly what we see that many factories still don't have optimized the use of the heat. So they have a variable load, and sometimes they produce heat in a more or less constant way, and sometimes even day and night. So there is already much to do in like saving heat and then producing less, and then you can afford maybe to have a slightly more expensive fuel that would be sustainable. We consider co-firing as a good practice to become familiar with the use of biomass, but it requires usually more space for storage. It requires mixing, and it requires skills. And the maintenance we'll have, in some cases, it depends on the biomass we're going to use, but sometimes the maintenance is going to be more challenging. So it means it requires more skills, and it really requires a strong support from the management in the factory, because it's going to imply more effort from the technical team. And our own recommendation would be that in some cases, maybe it's better to start securing the supply of alternative fuels before investment. So I'm really open to any common and other views on this, because I had the feeling that the factories were not as confident in their ability to source in a reliable way biomass as they are sourcing coal right now. Usually the biggest factories have several coal suppliers already, so they would have to do the same for biomass. And yeah, of course, we really encourage them to become confident in their sourcing before they switch their boilers, of course. Regarding operation, so another option to switch to clean heat could be to switch to electricity. So first, decentralized electric boilers. In our case, that was the solution we were seeing most, and it was really appropriate for factories that have more limited heat needs, especially for ironing and variable loads. So that was our recommendation, but mostly for smaller factories. Regarding market risks, so of course nobody knows how the biomass prices are going to evolve, because looks like there are some encouragement, if not incentives, from the Vietnamese government to make use of biomass for either electricity production or direct use to produce heat. And so we don't know how this is going to influence the prices. So it's in the next years. Of course, there are challenges on traceable supply chain, because if you remember in the slide on the prices, we had some biomass that was very expensive, and usually this one is the one that is mostly produced for export and that has labels, especially sustainability labels. And so that is not necessarily the most appropriate options for the garment factories that need a cheaper fuel. So the challenge is to ensure sustainability, maybe finding alternative traceability and control options that may not be already the existing, I don't know, FSC labeled pellets or yeah, I don't know. It's especially for the very, very large heat needs. And yeah, we have a question about the future competition between users. So we really don't know how it's going to happen. And I'm sure other participants and panelists may have much better answers on that. Next slide, please. Yeah, so that were the different options we were seeing for a switch to sustainable heat. We first co-firing as a first step, then burning biomass residues in incineration boilers for factories that were using fabric waste. Decentralized electric steam production can of course be combined with solar PV or with any kind of PPA, even distant PPA. And solar heat, I think, was very well introduced and explained by Mr. Jinley. So I'm not going back to this question, but of course, that would be great to see more pilots in the garment sector using thermal heat as well. Next slide, please. So of course there is when you do such a small study, you see many options for and ways for more research and more action to understand better and to guide further action better. So we really encourage the factories to conduct an assessment of their heat use and their steam production system, of course, and steam distribution. And we really encourage the close monitoring of any change when they switch to decentralized electric steam, or when they introduce some kind of water recuperation or water reuse or hot water recycling, to really document how much they can save through this different switches. We would like more feedback from factories that have experience in co-firing. We know from colleagues in GIZ that some factories are already experienced with that, and that would be great if some experience could be shared in the sector. We would like to understand better the barriers, so that's also something that would be great if it could be shared when factories try to switch or try to co-fire. So what happens, what are the challenges? So that is the reason why many factories prefer to switch to electric steam generation when they can afford, because the technical barriers and the skill barriers seem to be much lower. And also, yeah, space is more limited. Of course, there is a need for financial options, because when you see the investments that are going to be required in the factories that have large heat needs, so yeah, of course, any incentive and levers would be welcome. And I don't know much about that yet. I think, yeah, a lot of cooperation around the best options for sustainability and traceability that would be efficient and also have reduced costs. They also require common efforts and, yeah, shared results. We hope that the alignment of brand objectives are going to result in more affordable, sustainable heat for factories. And we also look for collaboration between diverse actors, so from the industry, from the research, from development partners, NGOs like us, and investors, so that we can move quicker. I think that's at the end. Thank you for listening.
Thank you so much for the insightful sharing, Alder, and also and breaking up all the different challenges in terms of financials and technology for replacing coal-fired boilers with biomass option and other options as well. And also, I'd like to thank Peter, for sharing H&M efforts and also your targets and very ambitious goals in the upcoming future. So my apologies to the audience in the press for time. We will save some of the questions for order for the panel discussion. And certainly we have answered some of those on the Q&A box. So with this, thank you once again to Order and Peter. And I would like to transition us to the next presentation. And certainly building on the foundation that Order and Peter have brought in terms of local context in Vietnam, we would like to, it is my honor to you to introduce the next speaker, Ms. My Lê, the head of sustainability from Heineken in Vietnam. And certainly, while Heineken is widely known among many of us as the world leading developer and marketer of premium beer and cider brands, perhaps we are less aware of their incredible efforts in embedding sustainability into their business and their carbon neutrality ambition by 2030. So today, we will have the opportunity to hear more about Heineken effort in biomass heat and then the impacts of such solution can have on the company. So without further ado, Ms. My Lê, the floor is yours.
Yes, thank you, and good morning. I'm very happy to try the webinar today, and I just see that the very good sharing this morning that I already received. And thank you very much for this sharing from the previous speaker. I love your your assessment and also your comparison between all the kind of energy. So I think that's very useful for all the one who like to do the business case for their renewable energy and how to apply the renewable energy in the thermal for heat. And yes, here I think I already see that there are very different challenge and also opportunity for different industry and also different corporate. Here I would like to share my our experience of using biomass heat in Heineken Vietnam, and because I think that the majority of participants today is Vietnamese, and also I also like to promote and to encourage the Vietnamese corporate to use renewable energy for heating. So that's why I will share my experience in Vietnamese. Yeah, thank you. I hope that you already see my slide. Yeah. Okay.
Yeah.
Have you seen my? Yeah. Okay. Thank you. Yes. Đầu tiên thì tôi xin được giới thiệu đôi chút về Heineken Việt Nam. Thì Heineken Việt Nam có 6 nhà máy trên toàn quốc. Và trong năm 2020, tuy bị ảnh hưởng của đại dịch Covid-19, nhưng Heineken Việt Nam vẫn rất là hân hạnh được góp được có những đóng góp tích cực cho nền kinh tế cũng như cho xã hội của Việt Nam. Cụ thể là trong năm 2020 thì Heineken Việt Nam đã đóng góp được 0,87% GDP cũng như hơn 180.000 việc làm trong toàn chuỗi cung ứng. Và như quý vị cũng thấy là ở góc phải của màn hình hoặc là cũng như cái background phía sau tôi thì năm nay, năm 2021 là năm Heineken Việt Nam kỷ niệm 30 năm thành lập. Và Heineken Việt Nam rất là vui mừng cũng như hân hạnh là trong suốt 30 năm qua thì Heineken Việt Nam luôn đồng hành cùng sự phát triển của Việt Nam trong cả 3 lĩnh vực là kinh tế, xã hội và môi trường. Về môi trường thì bên cạnh những cái hoạt động như là tăng cường việc áp dụng kinh tế tuần hoàn trong chuỗi cung ứng cũng như trong sản xuất của mình và bảo vệ nguồn nước, thì có một cái điểm mà rất là quan trọng đối với Heineken Việt Nam chắc là làm sao mà tăng cái lượng sử dụng năng lượng tái tạo trong sản xuất của các nhà máy của Heineken Việt Nam. Và trong năm 2020 thì Heineken Việt Nam đã đạt được 56% tỷ lệ sử dụng năng lượng tái tạo trong sản xuất. Cụ thể là nhờ vào 100% việc sử dụng thermal cho làm nhiệt năng biomass tại 5 trên 6 nhà máy của Heineken tại Việt Nam. Và cũng trong năm 2020, mặc dù là bị ảnh hưởng của đại dịch Covid, nhưng mà Heineken cũng đưa ra cái tham vọng là tới năm 2025 thì là toàn bộ các nhà máy của Heineken Việt Nam tại Việt Nam thì sẽ sử dụng 100% năng lượng tái tạo. Còn trong tháng 4 năm 2021 cho vừa qua thì là Heineken toàn cầu cũng đưa ra một cái cam kết là tăng cường cái tham vọng của mình tới năm chúng tôi gọi là cái chiến lược mà Raising the Bar năm 2030 chắc là tăng cường cái cam kết của mình tới năm 2030 là đạt để làm sao mà tới chúng tôi có thể đạt được cái việc mà không có tạo ra một cái ảnh hưởng gì đối với môi trường. và cụ thể là tới năm 2025 thì Heineken toàn cầu cam kết là tất cả các nhà máy của Heineken trên toàn cầu sẽ sử dụng 100% năng lượng tái tạo. Và tôi xin giới thiệu đôi chút về cái tỷ lệ sử dụng năng lượng tại Heineken Việt Nam, tại các nhà máy của Heineken Việt Nam. Thì quý vị cũng thấy là 40% là điện năng và 60% là nhiệt năng. Cho nên cái nhiệt năng chiếm cái phần khá lớn trong cái việc sử dụng năng lượng của chúng tôi. Và cách để mà chúng tôi đạt được cái mục tiêu là 100% năng lượng tái tạo trong sản xuất thì chúng tôi có ba cách. Cái thứ nhất là Biomass. Về Biomass thì ngoài cái việc mà sử dụng Biomass cho nhiệt năng cho heat tại tất cả 6 nhà máy ở Việt Nam thì chúng tôi còn hướng tới cái việc sử dụng Biomass cho điện năng, và chúng tôi đang thử nghiệm, đang tiến hành cái dự án thử nghiệm cái việc sử dụng Biomass cho điện năng tại một nhà máy Vũng Tàu. Cái phương thức thứ hai chính là điện mặt trời. Thì điện mặt trời chúng tôi đi theo hai hướng. Hướng thứ nhất là đương nhiên là sử dụng cái rooftop solar, chứ là cái điện áp mái tại tất cả các nhà máy của chúng tôi. Bên cạnh đó thì chúng tôi cũng theo đuổi cái dự án cái cơ chế mua bán điện trực tiếp DPPA, và tôi rất vui mừng là tôi cũng thấy là tất cả chúng ta đều biết là cái mua bán điện trực tiếp DPPA là một cái vấn đề rất quan trọng đối với chúng ta để đạt được cái chỉ tiêu 100% năng lượng tái tạo. Bởi vì ngay cả trong cái điện mặt trời áp mái thì cũng chỉ đạt đối với nhà máy đối với Heineken Việt Nam chỉ đạt được từ 5 tới 8% cái năng lượng điện mà chúng tôi cần thiết thôi. Và chúng tôi hy vọng là trong năm nay hoặc là đầu năm sau thì chúng ta sẽ có một cái tin vui về vấn đề là chính phủ sẽ ban hành cái cơ chế mua bán điện trực tiếp trong giai đoạn thử nghiệm. Và cái điểm cuối cùng chính là biogas. Thì cái biogas này là cũng do áp dụng mô hình kinh tế tuần hoàn ở trong các nhà máy của Heineken Việt Nam, cho chúng tôi thu hồi cái biogas này từ những cái chỗ mà từ việc xử lý nước thải ở trong các nhà máy, và chúng tôi cũng dùng cái biogas này để cho cái nhiệt năng của mình. Lộ trình sử dụng biomass nhiệt năng tại Heineken Việt Nam thì ngay từ năm 2014 chúng tôi đã bắt đầu thử nghiệm cái đầu tiên tại Đà Nẵng, và sau đó thì chúng tôi nhân rộng đến tất cả các nhà máy. Nếu mà đúng theo kế hoạch thì năm 2021 cho năm nay là chúng tôi đã hoàn thành được cái kế hoạch là sử dụng 100% nhiệt năng tại tất cả nhà máy. Nhưng mà do cái tình hình dịch bệnh Covid-19 năm nay khá là nghiêm trọng, cho đó chúng tôi đã buộc lòng phải dời cái kế hoạch của mình sang năm 2022. Và cũng tương tự như vậy là cái việc mà sử dụng điện năng biomass tại nhà máy Vũng Tàu theo kế hoạch là cũng đã nhớ là năm nay chúng ta bắt đầu, nhưng mà chúng tôi phải dời tới năm 2022, và hy vọng là cái dịch bệnh Covid sẽ sớm qua mau để chúng ta có thể đạt được cái chỉ tiêu này. Và nếu mà đạt được việc này thì chúng tôi sẽ đạt được 100% nhiệt năng nhiệt năng về biomass tại các nhà máy của mình. Còn về điện năng biomass thì chúng tôi sẽ đạt được khoảng 43% cho cái nhu cầu điện năng tại nhà máy Vũng Tàu. Quy trình sử dụng nhiệt năng biomass tại nhà Heineken Việt Nam thì khá là đơn giản, chứ là chúng tôi sử dụng chủ yếu là vỏ trấu và wood chip là những cái vụn gỗ. Thì chúng tôi sử dụng hai nguồn này là hai nguồn chính, và chúng tôi phải và sau khi những cái nguyên liệu hữu cơ này được chuyển giao cho tới nhà máy biomass thì nhà máy biomass sẽ sử dụng những nguyên liệu này để tạo ra heat, và cái hơi này thì sẽ được truyền qua đường ống để đến nhà máy bia Heineken Việt Nam cho ở nhiều công đoạn khác nhau, như nấu bia hoặc là khử trùng vân vân. Và đối với Heineken Việt Nam thì việc sử dụng nhiệt năng biomass sẽ đem lại những cái giá trị mà cho cả kinh tế, xã hội và môi trường luôn. Về xã hội thì là chúng tôi đóng góp tăng thêm thu nhập cho người nông dân cũng như cho các nhà buôn những cái vụn gỗ. Về môi trường thì sau khi sử dụng nhiệt năng biomass thì đã giúp giảm tới 50% khí phát thải CO2 của các nhà máy của chúng tôi. Còn về kinh tế thì rõ ràng là khi chúng ta cùng chung tay phát triển lên một cái nền công nghiệp năng lượng tái tạo thì rõ ràng chúng ta sẽ tạo thêm thu nhập cho nền công nghiệp này. Dạ vâng, và đây tôi xin chia sẻ những cái cơ hội cũng như những thách thức khi cụ thể là Heineken Việt Nam trong vấn đề mà sử dụng nhiệt năng tái tạo, nhiệt năng biomass. Cơ hội thì chúng ta đã thấy là cái phần chia sẻ trước đây, chúng ta đã thấy là trong biomass là một nhiệt năng khá là dễ sử dụng tại Việt Nam. Nhìn chung là bởi vì thị trường có sẵn, công nghệ có sẵn, nguồn nguyên liệu của biomass cũng có sẵn, giúp giảm thiểu CO2 Và cái risk đó, như cái bản phân tích của người chia sẻ trước tôi cũng nói là chỉ trong cái phần đó chúng ta nhìn thấy tất cả các mục đều là màu xanh, chỉ có cái phần risk là màu vàng thôi. Cho nên cái việc mà sử dụng nhiệt năng biomass là đây là một cái cơ hội rất lớn sẵn có ở Việt Nam, và đây cũng là một cái giải pháp rất là tốt để cho các doanh nghiệp đạt được cái chỉ tiêu, đạt được cái tham vọng về năng lượng tái tạo của mình. Tuy nhiên là chúng ta cũng có những cái mô hình nhiệt năng sử dụng năng lượng tái tạo khác, nhưng rõ ràng là biomass hiện nay ở Việt Nam vẫn là một cái mà chúng tôi cho rằng hấp dẫn nhất và hiệu quả nhất. Khác với phần chia sẻ trước đây của người chia sẻ trước đây của tôi, thì tôi lại thấy ở đây là đối với Heineken Việt Nam thì chúng tôi không phải đầu tư về mặt capex, tức là về mặt chúng tôi không phải đầu tư gì cả, bởi vì chúng tôi vẫn sử dụng cái nhiệt năng tái tạo này theo mô hình OPAS. Một điểm nữa là khi mà sử dụng về mặt cái này thì tôi thấy là vừa về mặt kinh tế, vừa về mặt môi trường luôn. Chứ là khi sử dụng mà nhiệt năng biomass á, thì cái lượng thất thoát nhiệt năng á, nó ít hơn so với sử dụng dầu diesel là tới 10%. Như vậy rõ ràng đây là mang lại tốt về cả việc kinh tế và môi trường. Và còn một điểm nữa thì tôi không để ở đây, nhưng mà người chia sẻ trước tôi người speaker trước tôi đã chia sẻ rất là kỹ là việc mà sử dụng nhiệt năng biomass thì cũng còn mang lại những cái giá trị về mặt kinh tế nữa, vì giá nhiệt sẽ rẻ hơn so với việc sử dụng dầu diesel. Đấy là những cơ hội. Còn thách thức thì sao? Thách thức thì đầu tiên là người chia sẻ trước tôi cũng đã nói về vấn đề mà bởi vì có nhiều và ngay cả nhà nước cũng đã khuyến khích về sử dụng biomass nữa, cho nên là mặc dù Việt Nam là một nước nông nghiệp có sẵn một cái nguồn biomass rất là nhiều về cả bã trấu, rơm rạ, rồi bã mía, rồi thậm chí là vỏ hạt điều, rồi vụn gỗ vân vân, nhưng mà rõ ràng là có nhiều người sử dụng hơn thì là cái
when there are more users of biomass materials, it is likely that the input cost would be increasing. But I don't see this challenge as big as the challenge that I am going to share now. First, we do not have to invest in boilers, or because but in order to transfer the heat from the biomass factory to our factory, we need land, and then the land should be adjacent to our factory, and the factory in Đà Nẵng used biomass heat in 2014, but why we started biomass heat in Quảng Nam?
Máy đã xây dựng lâu rồi thì rõ ràng là việc có sẵn một khu đất là một cái thách thức khá lớn. Đối với nhà máy mới xây, chẳng hạn nhà máy Vũng Tàu chúng tôi đang xây và mới xây thì là cái việc này thì không còn là thách thức nữa, nhưng rõ ràng đối với nhà máy mà xây dựng lâu đời rồi thì đây là một thách thức khá lớn, bởi vì nếu không có đất thì chúng ta không làm được cái việc này. Thứ hai nữa là về vấn đề mà cái khung pháp lý, thì cái này chúng ta đã chia sẻ khá nhiều. Nhưng hiện nay đối với nhiệt năng biomass thì chúng tôi không còn phải mắc phải những cái khung pháp lý gì nữa. Những năm đầu sử dụng thì là đương nhiên chúng ta cũng bị gặp phải những cái khung pháp lý này. Nhưng hiện tại thì nhà máy Heineken Việt Nam đang bị ảnh hưởng về cái khung pháp lý đối với điện biomass. Thì vì rõ ràng cái này trong chính sách cũng chưa có. Và đương nhiên nếu mà chúng ta đi đầu, chúng ta tiên phong thì chúng ta luôn gặp tại một số những cái thách thức rất là lớn về mặt khung pháp lý, làm sao để hỗ trợ cho cái việc mà sử dụng điện năng biomass tại nhà máy Vũng Tàu. Tuy là không có phải đầu tư về mặt capex, nhưng ngược lại thì rõ ràng là để cho cái đơn vị, cái người seller, cái biomass supplier hay factory á, họ đầu tư để họ xây dựng nhà máy của họ thì chúng ta phải có một cái cam kết về hợp đồng lâu dài đối với họ. Thì tôi thấy xem đây là một cái thách thức mà chúng ta cần phải xem xét, bởi vì rõ ràng Việt Nam là một nước đang phát triển, cho nên những thay đổi về kinh tế cũng như về chính sách làm khá nhiều, mà nếu chúng ta phải kiếm cái hợp đồng ít nhất là 5 năm theo kinh nghiệm chúng tôi, còn không trung bình là 10 năm, thì rõ ràng trong khoảng thời gian dài như vậy thì sẽ có những thay đổi mà nó có thể trở thành những cái risk, chứ là những cái mà chúng ta cần phải để ý tới. Dạ vâng, ngắn gọn đó là phần chia sẻ của việc mà Heineken Việt Nam sử dụng nhiệt năng biomass tại Heineken Việt Nam. Xin cảm ơn.
Cảm ơn chị Mỹ rất nhiều vì đã chia sẻ các cái thành quả thực sự rất ấn tượng của Heineken trong quá trình sử dụng nhiệt năng lượng sinh khối. Và chắc chắn là Tùng cũng thấy đã có rất nhiều câu hỏi cho chị Mỹ về cụ thể về các giải pháp mà bên mình đã sử dụng, đặc biệt là giải pháp về OPEX, cũng như là các cách và các khó khăn mà mình sẽ gặp phải. Tuy nhiên là do mình cũng hơi trễ một chút xíu về mặt thời gian, cho nên Tùng sẽ xin phép giữ lại các câu hỏi đó cho quá trình thảo luận sau. Tiếp sau đây thì Tùng xin phép giới thiệu qua chị Trâm Anh bằng tiếng Anh. So coming up next, certainly, thank you so much, firstly, to Miss Me, and we would like to transition to our next very wonderful sharing from Ms. Trâm Anh, the Managing Director of Vietnam Cluster from Coats. Perhaps many in the audience has known Coats over the years as one of the world's leading industrial thread company with its pioneering history in the UK. Today, we will, similar to Heineken, we will learn more about the company's net zero targets and also its effort in replacing coal fuel for boilers. So without further ado, Ms. Trâm Anh, the floor is yours.
Thank you, Tung. Thank you very much. So it's a really great time for all of us to gathering this morning in the backdrop of the upcoming COP26 to talk about the thermal decarbonization, because it's also the commitment to reduce the emission in net zero, right? And I really feel that we have a lot of insight from the previous speaker, and also sharing very detailed and inspiring from Ms. Mỹ from Heineken. So now in the next in the next 10 minutes or so, I would like to share with you the journey in course in the thermal decarbonization and also our ambition in sustainability. Let me allow me to introduce a little bit about cost. Our bubbles, our company originally in Glasgow, England, and with the bubbles to connect the talent, the textile, and technology to make a better and more sustainable world. We are home in across the continent in 50 countries, and we in the location that where customer based to serve to customer with speed and also the least carbon footprint thanks to end-to-end supply chain. In Vietnam, our presence already have more than 30 years, and we have 2 factories in the north, Hưng Yên, and in the south, Ho Chi Minh City, with 1,800 employees. Our product is a very next to your skin, that is a thread to connect the fabric or the leather in your clothes and in your footwear. So we talk about sustainability, and we also see that consumerism now is more and more have awareness about this. It's a result of the planet and also commit to have a better life for the people and also next generation. You also see that more and more the brand, they have a commit and also raising the bar for the sustainability. It's a very good that today we hear from H&M, and Peter also share what is the ambition for H&M in that journey. I think that for our business now, sustainability is not that nice to have like before, but sustainability is a must and in the center of any business decision in our daily life. In course, because I just say that our purpose to make and have a better sustainable work. So we already have connected with our supplier and also the customer to alignment about the ambition for sustainability. I am not talk to all the thing here because you can have the slide later or even the video in the chat box. I just mentioned 2 things here. If you look at the energy column, the second column in the left-hand side, beside of the review emission action that I will share later, we also register on science-based target as a committed to achieving emission reduction because we think that is the right thing to do, and also it's our contribution in protect the planet. Or if you look at the living sustainability in the right-hand side, this is before we say that we need to have a recycled product to supply to our brand. But recently we also focus on circularity, and we also join up an Ellen MacArthur Foundation, in which it have a motivate for us to join up with our customer, supplier, and accelerate transformation for our industry. You also hear from other about the presentation for how to make the most sustainability for H&M. It's really the huge challenge, and it's really require the collaboration across the supply chain to achieve the target. Now I will take you back 7 years ago, where in cost we use fossil fuel to generate the steam. And I think that all of us here also interesting about the environment. So we also know that when we burn the fuel, it's also released carbon dioxide, the greenhouse gas, and it's also trapped into the air and cause the global warming and also the raising the sea level. And when we look at about this, it also take a lot of us about operating costs or maintenance costs, and also how to control, how to reduce the emission harmful to the environment. It's really the headache for us. Then we think that it's the time for us to more focus on sustainability and protect the environment. And we would like to do something in Vietnam, where we have the big factory in Hưng Yên and also Ho Chi Minh City. I think that for the challenge that Miss Mỹ already shared very detailed in previously, we know what we need to achieve, that is reduce emission, but a lot of questions raised at the time because in 2014 actually it's not have a lot of option and also availability for us. So we have the question related to, for example, CAPEX or OPEX, the technical support, the space, and also justification of reduce the carbon footprint. I also see quite a lot of questions about how we define that biomass is a renewable energy. And when we calculate, we see that carbon dioxide released in the air from biomass or from fuel is quite similar in the same ton of steam. However, if we look at about circularity of biomass and fuel, is quite different. And then it took us about 1 year for searching the solution and also who can supply for us. And luckily that we found one company called Cháu Việt. I think that when you look at the name, you know that what is the material we are using here is a rice husk. And we see that rice husk is renewable and it's a near carbon neutral, and also it's a massive in Vietnam, because we are the largest or the second largest exporter in rice in the world. So it also have quite a lot of challenge about the long-term contract, but finally we have the partner with that supplier to supply to us, and they also handle for us everything. Then we just need to manage like the expense. The most important I can see here, because it takes a lot of investment for them. So we need to share our projection or our forecast so they can prepare to meet our demand. Then we are thinking of biomass as a replace fossil fuel. It's just a replacement. But look into the sustainability, we need to think about the reduce or reuse. So now I take you through another one that we are doing to have a thermal decarbonization, that we are reuse our heat from dyeing process. I think that for course our scale for this maybe just small, but for the garment manufacturing, like Peter or Odette mentioned before, it will be huge. We utilize the heat from the dyeing process to heat the fresh water, and based on that, we reduce the heat energy for the dyeing process in the next time. And it's also help us to reduce the heat for the water go to the water treatment plant, and again, reduce the energy for the cooling water. So we can see that based on utilize the heat from the previous process, we can save a lot of energy, and also based on that, reduce the emission to the air. So in summary, I can say that the project that we have going on just clear the myth for us that sustainability is costly. It says that sustainability for environment is sustainable for the business. We can see that what is the thing that our company or your company will earn, that is enhanced reputation. You feel pride because you are doing the right thing, and also associate the saving. In the case of biomass, I can say that we are saving about 40% compared to before. We also feel proud because we have contributed to the clean environment, and we help the farmer and agriculture industry in Vietnam. For the brand and consumer, we proud that we are participate in the supply chain, and the customer also feel that they have a reliable and also sustainability supplier for them. In the end, it is for the planet, and we can save this beautiful planet for the future, next generation. So that's all for my presentation and sharing today. Now I'm open for the question you can raise in the next session. Thank you.
Thank you so much, Ms. Chomeng, and for the wonderful insights on Code's ongoing journey with rice husk and also the heat recovery process. I bet the audience, there are so many questions right now, so I'll leave the floor back to my colleagues. Evan, for sure, take it away.
All righty, thank you, Tung, and thank you all panelists, and thank you to the audience, recognizing that we still have over 100 people here, almost an hour and a half into this. So real quickly, we're going to close out our 90 minutes, what we're calling the main event, with about 7 or 8 minutes of questions to our panelists to hopefully capture some of the things that we weren't able to ask along the way. I know we threw a lot of really useful but complex information at you over the last hour and a half. So we'll try to draw out a few things in these last few minutes. However, we recognize most folks do have jobs they need to get back to. If you need to leave the webinar at the top of the hour, we recognize that. So the end of the conclusion of this event is in 6.5 minutes, but we are having what we're calling a bonus session focused on some of the learnings that CEI took away from a recent study that we did earlier this year with Nike, looking at Nike's manufacturing supply chain in Vietnam, particularly on rice husks, which we definitely heard rice husks discussed today. So we'll have some other learnings to dive deeper into for a bonus 15 or 20 minute session that will start at 10 at the conclusion of the main event. So hold tight. Please stick with us if you'd like to hear that study. But yeah, to bring our panelists together, I see a couple of you unmuted and on video. So if the other panelists, Pete and Jin Lei and Odd, if you're able to unmute yourself for the last 5 or 6 minutes. Lots of questions. We definitely won't cover everything, but I just want to ask one thing, and I'll throw this out to any of the panelists. If I was in the audience and I was an industrial energy user and I was hearing all of these things, I would take away a few things. Wow, there are a lot of challenges out there because depending on what sector you're in, if you're a garment manufacturer, if you're a brewery, if you're in paper manufacturing, each of those companies has different needs and demands for different heat processes and different temperatures. So it's complex on the demand side, and then also, as we heard, there's a variety of different solutions to consider too. So kind of looking at that, there's not one single answer to each problem. Where would any of the panelists suggest is like the best or the easiest or most actionable place to start in terms of, you know, from the perspective of an industrial energy user wanting to learn about, evaluate, and move towards a procurement of lower carbon heat? Where's a good place to start, a simple place to start? So kind of a broad question. I'll toss it out to any of the panelists that want to take that.
Ivan, I like to start a little bit here. For me, in our company, we have the slogan say, "Fit the basic." Yeah, it means that when you look at all the heat that you are using, firstly to see that is it you use effectively, and also with a lot of technical now, if you can reduce the heat that you are using, do it first. So that is the first thing I just like to say. Yeah.
Great point. Yeah, and that did not get clearly said today, but yeah, look to be more efficient and reduce your demand before you look at new solutions. Great point to highlight. Maybe a question that I'd direct to Odd and Pete, because you did this wide-ranging study looking across H&M supply chain. So I know this answer is specific to garment manufacturing, but you guys did evaluate. We saw that nice matrix of multiple solutions. What stuck out to you in that in terms of you know, the lowest hanging solution or the most cost effective or most actionable solution in that study?
Ord, we go first or me?
You first.
Okay, thank you. I guess, I mean, what stood out most of the study was simply that as of today in Vietnam, finding biomass-based solutions definitely involves the least investment changes and the least physical disruptions to supply chains and production. I was hoping that the study would be more optimistic about solar thermal and really showing that was a more developed in the Vietnam market and ready to expand. That is something obviously that we would like. You know, the limitations to biomass in the long term are well known. As has been discussed earlier as well today, the definition of sustainable biomass is also probably going to change at some point as well. So finding solar-based and electric solutions is ideal. The study, suggests that at least in the short term, biomass is the most feasible, and therefore, you know, very excited to work on ways to improve that. Are there ways that supply chains around biomass can improve? Storage and drying, therefore improving that moisture content and efficiency. Ord's study raised all of these important things that H&M Group is now looking at doing. And you know, if anyone else here in the room wants to help us on that, we're more than happy to talk on any of these topics. Thank you. Ord?
I'm just gonna say what we energeticians always say, and the first step is sufficiency. So just consume the heat you need, then efficiency, have efficient appliances, and then meet your needs with renewable energy. That's the right order.
Great, thank you, Pete and Odd. I know we have about 1.5 minutes until we hit the top of the hour here. I'm going to end with a tough question, but one that came up in terms of how do we open up the market? How do we bring more of these new technologies that we don't see today in a widespread way in Vietnam? How do we scale those up in Vietnam? And policy always comes back to policy. So Odd, I'll start with you on this. I think I heard you mention during your presentation that the Vietnam government may be thinking about some incentives related to industrial heat. So I just wanted to clarify that. And then the broader question for the rest of the group is, if you had to pick one specific policy mechanism or regulation that could kickstart and spur the wider scale use of more clean heat solutions, what would you suggest that one policy mechanism or regulation be?
No, but I, of course, right now, I think I'm not sure there are incentives. I think there is a law, but I'm not sure there are incentives. But you could think about like decreasing the VAT on biomass boilers and increasing it on coal boilers, things like that.
Good, good. Well, I know we're at the hour, so any other panelists that want to put out policy related ideas? And I'm selfishly asking this because if you've engaged with our CEI team before, this is where we intersect, where we look for the barriers in the market, and policy always comes into play, whether it's thermal energy or electricity. And we want to be able to identify some of those policy and regulatory interventions where we can all work with the private sector on. So any other ideas that you'd throw out to the audience and also to us at CEI?
I think from our side, it would be policy around the phasing out or the ending of coal power, at least kind of on-site generation for some units. I know under the UNFCCC's fashion charter, fashion brands have committed to not onboarding new factories with coal at 2025. If the Vietnam government wanted to find ways to bring that kind of date earlier, I think it would support the industry, factory managers and everyone as well. So being a bit stricter on that would be a policy framework I think we would support.
And we saw a question, we should wrap up here. I saw a question from Liam a few minutes ago about looking at regulations on air pollution. And so I think that's a question maybe we explore in our next webinar looking at thermal energy, but could more stringent regulations on air pollution be a catalyst for companies to switch to cleaner thermal? So I wish we had more time. Every time we do one of these webinars, we end with on that note saying we wish you had another hour. So if you do need to drop off here and move on with your day, just want to say thank you so much for the 90 minutes that you spent with us. We hope it was useful. As noted, this was recorded and it will be shared. There will be a recording of the link shared, as will most of, if not all of the speakers' PowerPoint. So you'll get all of this material. And lastly, I will encourage you, if you did not get your question answered, stick around and use the Q&A box and ask the speakers directly in writing in the Q&A box, and you might be able to get some answers in the remaining minutes. So we will pause there for the main event and transition over to what we're calling the bonus session, in which my CEI colleagues, Ms. Hong Dao and Roby Robicho, will be talking through the findings and the learnings from this in-depth study that we did in partnership with Nike earlier this year. So I'll pass the microphone over to Hong and Roby and say thank you again to everyone else in the audience, and especially to all of the panelists and speakers today. Really appreciate all of your time. Thank you.
Thank you very much, Evan. And I want to thank everyone for having us here tonight. We appreciate it very much. I'm Roby Robichaud, Renewable Energy Technical Research Lead for WRI. And we're going to be presenting with Hong Dao, who heads up our WRI Vietnam office. During the past year, we did a deep dive for Nike into the potential for converting some of the apparel supplied factories in Vietnam from coal to rice husks for their thermal process heat. And this presentation would like to illustrate and explain some of what we learned through this work. Hong, the floor is yours.
Thanks, Roby. Good morning, everyone. Again, thanks everyone for staying on until this hour after the so-called the official time of the webinar. So I'm very happy to carry on with this bonus session, so to say, with my colleague Roby. So I'm Hong Dao. I co-lead CEA Vietnam, and also I'm with WRI Energy. And as Roby mentioned, so we have this small study collaborate with Nike supply chain in Vietnam, and yeah, so I won't let you wait for too long. Let's dive into the content of the this presentation today. So, you know, this first slide, if you have seen our previous speaker mentioned about the, you know, the power generation profile of Vietnam. So in the graph on the left, you can see the fuel source, the mix of energy mix for electricity in Vietnam. And what we want to say that this, you know, this mix could be different from what the factory actually are burning for their industrial thermal process. And what we want to show that this kind of mix usually indicates the fuel choice for the factory from the generation source, whether it's electricity or heat. And this energy mix also help us to explain the current economics and as well as the impacts of the current national policy regarding power generation, and help us to identify opportunities where the new policy can be developed to support more, let's say, the sustainable biomass conversion for Vietnam. As you know, you see in the graph, we have a very short amount of time for the solar boom in Vietnam, but it just account for a small portion of the whole energy mix. So it could be an open for a new policy to support more for renewables biomass in Vietnam. Next. And the next one, we wanna share insight with you a study from our colleagues from GIZ. So basically, this graphic and the study talk about the waste of bagasse or the sugarcane for the bioenergy power plants, and this is very kind of particular market features to note that, you know, there's an annual impact from a fuel stock in this market based on the weather as well as based on the crop that grows in that year. And the next one we want to highlight in this study is that we want to share about the barriers that hinder the access to finance, as well as the reduce the potential to install this kind of biomass fuel in many countries. So the aim is that we want to support and to provide more assistance to reduce these barriers by providing technical assistance, technical expertise, as well as, you know, promoting collaboration, as well as the sharing more experience case study around the region and Vietnam. So you can see yourself some of the barriers identified in this study, varying from knowledge deficient to policy to finance. So that's where we need to collaborate and work together in this matter. Next, and the next one we like to show you is a brief of the, you know, the biomass market supplies that we studied in Vietnam. One of the interesting key factors we want to show here is that, you know, the distance from relative concentration of rice meal in the Mekong Delta is it quite close to the supply source of the coal-fired boilers at the factories. But at the same time, you know, we have the so-called potential or the actual another source of uses for the biomass is a brick making. or the so-called the brick kilns are also located in clear or close, near or close to the rice mill, obviously to keep their costs down. So there's the potential or the actual competing use of the rice husk in this sense. And the study we found there's show that 40 to 60% of the available rice husks are used for these brick making factories in the Mekong Delta. So this is one of the highlights we want to show you through this study. Next slide, so this is another interesting study that we want to share with you. So basically, when we're looking for opportunities of bio-waste, it's important for us to differentiate the potential of the waste stream and the actual kind of processed products that can be used at the factory. So so in this graph, you can see the magnitude of the agriculture crops, and we're not just talking about only the rice husk, but this is shows you a list of biomass resource or agriculture waste potentially in Vietnam, and the interest we want to show you the crops that have the harvesting residues, as you can see in the green bar here. The numbers show the annual crop harvesting residues, and it shows that we have a very high potential rice straw in the field after the harvest, or in Vietnam you're very familiar with where the rice crop is harvested and they leave the rice straw in the field. So, and it shows in the graphs, we see that growing rice products have the most waste residue in the field. However, we have challenging and we have issues with the rice straw because it's a quite wet product. It could be bulky, sometimes messy, and dirt with soil. So it's abundant, but also a challenge for the processing, and it could be challenging for the logistic itself. So in the next slide, we want to show you another the number for comparison. The interest here is the rice husk or the crop processing residues, or the quantity of the when we look at the processing residue, the quantity of other agriculture waste compared to the rice husk is more let's say balanced, and the quantity of the agriculture waste at the factory are larger compared to the previous one where that is harvesting at the field. So we estimate from various reports and study for the last 5 to 15 years that 50% of this say processing residue is still used in the brick making factory, and about 20% of it used in the rice mill for drying or for the related to the food drying and other agriculture product processing, and that leads to the rest 20% of the annual rice husk is supplied for the market for other use of the boilers and heat generation. So with that kind of the overview of the the background of the market that we're looking at, I leave it to Roby to carry on to give you more insight about the study that we are working with Nike. Yeah, Roby, the floor.
Thank you very much, Hong. So the rice husk availability is directly correlated to the rice crop production. No surprise, if you have 3 annual harvests at a field, it will produce more rice husks than if you have just 1 or 2, lending itself to greater market stability and product availability. We can see from this aerial graphic, the green shaded areas represent irrigated triple cropped rice farming. The yellow and tan areas are both double cropped. The tan are watered through irrigation and the yellow rely on rain. In the marketplace, it's challenging and expensive for rice husk suppliers to store a lot of rice husks over long periods of time. It must be kept dry and its value will decrease when the next rice crop is harvested. Seasonal price variability is expected if you're doing just ad hoc purchases. Also of interest to note, in the 2007 study, 50% of the rice husks were produced in the Mekong River Delta, about 20% in the Red River Delta to the north, and the rest were scattered throughout the country. In the north, the Red River Delta area, most of the rice is single or double cropped. The winter temperatures are too cold for that 3rd crop. Just taking a simple look at the benefits of rice husks. It's much better for the environment than coal. It's a convenient fuel, readily created when processing the rice food product. And when dried and pelletized, it's an effective fuel and it works well in a variety of furnace, boiler, or heating systems. All of you know rice very well, but for those of us who don't, just a quick illustration. There's various forms that we're talking about. Here's the full rice paddy shipped to the factory. The rice husk is separated from the paddy grain, which is the food product. Loose rice husks can be burned, but they're kind of bulky relative to the heat content as fuel. So it's far better to compress them and decrease their volume and increase their energy density. The rice pellets can take several shapes. They're all dried and compressed with the intent of providing a lot of surface area for rapid high temperature burn, while also taking up less storage space and being easier to transport and store. Note the briquettes are generally considered to have both great rapid burning shape with the large hole and surface area. We did a market survey, talked to a lot of suppliers directly, and some of the highlights weren't worried about any risk of rice husk shortage or wood chip shortage across Vietnam in the near term. In the south, the concentration of rice mills is higher than in the north because more rice is grown, greater availability of the rice husks. Costs varied quite a bit with suppliers from $110 to $190 per ton, depending on the type of pellets or briquettes in the season. Price trends generally increasing since 2017, maybe due to more use in rice paddy drying at the production facilities, or also some of the people talking today said they're using it in their factories as well. So that could be the cause. We couldn't find real confirmation of that. Multiple modes that vendors operate by, they prefer the longer term contracts, 5+ years. One surprising item that Hong found was that they prefer to sell heat as a service or selling steam rather than rice husk pellets as a commodity. And the vendors all indicated that they would respond to RFPs and that sort of thing if they're out there. Our team also needed to learn more about factory operations themselves, especially in regards to conversion cost from coal to biomass boilers and the impact on the operations. Nike allowed us to create a survey which they delivered to 7 of their factories in Vietnam that had previously converted either partially or completely to rice husks or other biomass fuels. You can read some of these highlights while I talk about a few others. Though transportation distances may vary, most contract with vendors more than 80 kilometers away. This was surprising given what we heard from the rice biomass vendors. Factories are closely split on the use of pellets versus briquettes. Most factories contract with a supplier for 1 year. Again, surprising. per what the vendors told us. Half the factories use a competitive RFP with very specific sourcing criteria. And the factories did not cite the need to construct or add more on-site storage due to making the conversion from coal to rice husks. Another surprise for us. And probably the most important item to flag, if doing the conversion again, more attention should be given to efficiency and system optimization. You're going to be using this system for a long time. Get it right the first time at the beginning, and it will pay dividends for years. We've researched a lot of different studies. This one on the right had a very interesting supposition, and it basically said that the energy cost at factories dwarfed all the other operating costs, shown here at 87%. Raw data wasn't available, but it was an interesting graph that got our attention. We didn't have all the data we needed to do a full life cycle cost assessment to determine how much the biomass boiler purchase would impact operating the factory and its costs. So we decided to use the results from the study to get at least a perspective on the impact of those equipment costs. So what we did is, first we looked at the hours of operation. In a typical US factory, it might be 2,000 hours a year, but these supply factories are operating 24 hours a day, 6 days a week, and over 7,500 hours a year, 3.6 times more than the average factory. So then what we did is say, well, okay, what if we took this cost, and we know normally in accounting you would amortize it over time. We said, how about if we break it down first, cost per year, then cost per day, and cost per hour, and then compare it to the fuel cost. So in essence, I've taken a capital cost, and by breaking it down to its hourly rate, it now looks a lot more like an operating cost. So here we see the fuel usage out of 12 different coal burning factories that we studied. And just for your reference, the green rows here are the factories where we recommended converting to rice husks based on the cost savings. They were paying a little higher price for coal, and the price for rice husk would be cheaper. So you can see how much fuel they're burning monthly, how much it cost monthly, and then we converted that to an hourly cost. And like I said on the previous slide, we took what the cost of the biomass equipment was on an hourly basis. And now as we compare these two, you can see the cost per hour for the fuel is huge compared to the cost per hour over a 20-year useful life of the biomass equipment. So it certainly dwarfs the impact if you spread it out over the full life. Now, this isn't exactly an apples to apples comparison, and it's not the only basis for making decisions, but it does highlight looking at various ways of assessing cost with processes. Some of our summary findings, we did a lot of different research, and we had surveys with factories that did the conversion and then with suppliers, et cetera. What we found is if all of the factories were to convert, the emissions reduction would be 702 kilotons of CO2 equivalent per year. Nike doesn't get all of the product from these factories. Their share would be 261 kilotons CO2 equivalent per year. For factories that operate 24/7, the CapEx cost of new biomass boiler equipment is relatively small compared to the cost of fuel, as we illustrated on that previous slide. There are very large quantities of rice husks available and generated every year, but it appears from our studies that maybe 60 to 80% already have current uses. So trying to obtain them would probably cause some sort of bidding war. Market stability is determined by rice husk availability, which is impacted both by the rice husk harvest and the number of annual crops. And then the market price is influenced by the rice husk availability and the competing uses. So with that, that wraps it up, and we want to thank you very much for staying on this late into your morning, but appreciate your time. Let's see if we're all back. So Evan, I'll turn it over to you as the MC, but if there's questions, we're happy to try to answer them.
Yes, recognizing that we are well beyond time, I think it'd be difficult to address the many questions that we saw, but I see this. Thank you for sharing the screen. On a parting note, we will be sending you all in the audience many things next week. So to keep your eye out, if you registered for this event, that means we have your email, and we will email you next week with a few things, particularly pertaining to this study that we did with Nike. We will be having this, what you see here, a 2-page infographic that boils down and captures the key points that we'll have available next week for download. So we'll send you the link to that. And then zooming out, just thinking about the last 2 hours of discussion, we will also be sending you what we call a post-event summary write-up. So we'll be putting into writing the key points and the key learnings that we all heard and discussed here today into a nice, clean 2-page document. And then in addition to that, we will also be sharing the speakers' PowerPoint files. So if you're interested to dig into the details, you will have access to those files. And then lastly, in that email that we send to you next week, we'll be including a link to the recording of today's event. So you can go back and watch all of this again if you feel the desire to replay and re-listen to some of these insights. So we'll be sending a lot of things your way. In the meantime, again, on behalf of the Clean Energy Investment Accelerator team, thank you for sticking with us for a solid 2 hours. Thank you to the panelists and the speakers that I still see are here. Thank you again for your insights today. Very much appreciated. And on a parting note, I know Tung Ho mentioned this at the very top of the event. For the Clean Energy Investment Accelerator, historically in Vietnam over the last 4 years, we've been essentially exclusively focused on the electricity part of corporate decarbonization. How do you source rooftop solar PPA, or how do you look at the direct power purchase agreement pilot program, the DPPA program, the electricity challenge? But today, this webinar today that you all joined us for marked CEI's first foray into having a webinar that's fully focused on industrial heat decarbonization. So today was really the first step in that, and wanted to highlight to all of you, we plan, CEIA as a team, as an initiative in Vietnam, plans to scale up our programming and our efforts on industrial heat decarbonization in Vietnam moving forward, and the remainder of this year and certainly into 2022. So that will mean future webinars for the RE buyers working group. Just like today, we'll have future webinars that are fully focused on industrial heat decarbonization. But as many of you know, we do other things beyond and outside of the working group. So looking at in-depth technical studies. If your company is interested in exploring that, give us a call. We obviously just highlighted the work we did with Nike. We do in-depth work with companies to really look at analysis. And then as you might know from some of our previous work on the electricity side, we also look at supporting procurements and transactions to help companies start to get early stage projects in the ground and across the finish line. So all of those things, from the working group to analysis and studies to hopefully also looking at pilot projects and transactions, we will be focusing on that in the industrial heat decarbonization space. So want to leave you with that thought. Please send us an email and let us know if you have ideas. Let us know if you have suggestions. It's certainly something that we are looking forward to rolling up our sleeves on starting today and moving forward. So thank you, everyone. Really appreciate your time. And with that, we'll close out the event and keep your eye out from the email from us next week with the package of today's materials. Thank you, everyone.
Thank you, everyone. Have a good day. Have a good night.
Thanks, everyone.
Thanks a lot.